Hi everyone. So please read the question, pause the video, try it, and then continue. Right? Okay, let's look at this. This is a there's a simple trick in this question. There's nothing in this question. The question setter has tried to trick people. Before I teach what the trick, tell you how to solve this question, let me just talk about something else. Let's say we have milk and water, and their ratio reverses in the sense they have two different solutions. In one solution, I say there is 30% milk, let's say, then obviously water would be 70%. If it gets reversed, then I say that milk has become 70% and then water has become 30%. Now just concentrate on, let's say, milk's concentration. What do you observe here? You will say, well, if I take 30% milk and 70% milk and I mix them, then in equal quantities, I should get 50% milk. Yeah, because that is the arithmetic mean of 30 and 70. Don't you observe that these two actually add up to 100? They do. And this is something that you will always see. So if I tell you that there is a concentration, so let's look at another example. Let us say I give you a container and I say the milk percentage in one of them is 28%. And then this is container A. Then I give you another container, let's say container B. Yeah. And I say in this, what has happened is milk and water ratio has been reversed. What would that mean? It means water would have become 28% and milk would have become 100 minus 28%. Yeah. And that would have been 72%. So whenever there's a reversal of ratio, there are two ways to look at it. One way is you could say if it was X percent initially for milk, it will become 100 minus X percent. Or you could say that the two percentages of, let's say, percentage one, and when it is reversed into percentage two, would have their arithmetic mean as 50. That means they will be symmetric about 50, which means if I mix them in equal quantities, I will always get 50% as the ratio, which is 1 is to 1. This is what it is. Now let us look at, with this understanding, right? Let us look at the question. The question says there's a container 1, so I write C1. The ratio is P is to Q. This is milk to water ratio. Yeah. Then there is C2, where milk to water ratio, yes, has been reversed to Q is to P. This is what it says. And the volume, okay, so we'll write the volumes on top, but we'll come to volumes later. Then there's a container 3, which again has milk to water ratio, P is to Q. So I can say that these two containers actually have identical ratios, which is P is to Q. So if I mix all three of them, then the volume of container 1 and container 3, which contain P is to Q, should add to form the volume of container 2. Yes, only then will I get the mixture as 1 is to 1, which is my desired ratio. So volume for container 1 is given as P plus Q. Volume for container 3 is given as 2P plus Q. So what they want to do is they want to know what container 2 ratio should be. So it is nothing but P plus Q for container 1 plus 2P plus Q. Yeah. And this is equal to 3P plus 2Q. So hence, in this question, the question setter is actually trying to confuse you, and you may be tempted to use very long methods to solve it, where there is a very small way to approach this question and solve it. I hope it makes sense, right? And if you practice more, then you'll get better at it. So there's a good concept that you learned today. Okay.